Hello there. You are listening to Through Time and Clades. My name is Albert.
And I'm Joan.
Wonderful. Yeah, so it's been a little while because we've been pretty busy. I suppose we could talk a little bit more about what's been going on if you'd like. But yeah, we're back again, and this time we're gonna bring you some news from the world of nature that came out during January of this year. I know it's March now, but we think we can still do February as a separate episode. So we're gonna do that. But yeah, this year is off to a pretty good start, at least as far as kind of scientific publications that we're interested in goes. What's been up with you?
Well, I am happy to announce that this has been over 2 years in the making ever since we started this show. I've been teasing and hinting about this house and this land that my folks purchased that they've been building, and I've been giving little hints here and there, like, oh, we have the padding and the foundation. I can finally say that I am sitting here more or less fully moved in into our mostly finished home. So I'm finally here. Um, and it's nice. It's very nice. I say mostly finished because there's of course construction deadlines and bank loan stuff that my folks had to deal with. So we couldn't finish everything like exterior decor wise that we wanted to. But like as far as like the essentials, air and heat and that sort of thing, we got it. Yeah, and we're all slowly moving all of our things around and arranging them in the way that we want. And it's been kind of exciting for me because it's almost like a prolonged second birthday,
Hmm.
because we had these two storage units that were just full of our things, and a lot of my stuff, especially a lot of my books, had been packed away for 2 years. I haven't had access to them. So now that I do, I'm like rediscovering things that I bought years ago. I'm like, oh my gosh, I forgot about this, and oh, this will look really nice. Um, so it's just been really fun and exciting and a little bit stressful, but overall pretty good. I think to kind of sum up all of our thoughts, like me and my folks, um, we're pretty happy and we're glad to be in here. Um, and the neighborhood is very luscious and naturey. And already we've just been having so many wildlife encounters, deer at night, um, um raccoon prints. Apparently, my mom talked with one of the neighbors, and we actually do have black bears around here.
Wow.
So that was kind of a surprise, but also not really, because I mean, considering all the other critters that I've seen evidence of, including coyotes, I wouldn't have been surprised if bears were around here. There's a lot of forests that stretch out quite a ways, and just the biodiversity here compared to even like the Dismal Swamp Park in the summer that I grew up with is very high. So I'm very pleased with that. But yeah, it's really been like the biggest thing with me. Certainly recovering from the move, because yeah, we pretty much moved a couple tons worth of stuff from those storage units over a very small period of time. So you can imagine I'm kind of like, it's like my
Right.
goodness. Um, but it's all good. I'm really happy about it. What about you, Amico?
Yeah, well, first of all, that's all really wonderful to hear because obviously it's been a long time coming, and I've had my share of moves throughout my life, and they're always a pretty big undertaking, even the relatively small ones, as in like relatively small amount of stuff to pack and short distance. So I can only imagine how what it's been like for you, and I've never actually had a situation where I've moved into like a completely brand new house built from the ground up and like uh, according to our specifications. Um, so that's really quite something, and it's wonderful to see it all come together in the end. But as for what I've been up to in the last little while, um, in some ways, not too much special, I guess. Mostly I've been busy doing my research, and that's progressing pretty well. I've made a lot of progress, but nothing that's really worth sharing just yet. Um, I've been doing a little bit of teaching. I gave a guest lecture for one of the earth science courses here at the university about phylogenetics, which is mostly what my research focuses on, the evolutionary relationships between different organisms. And that went pretty well. It's sort of an intro to phylogenetics for earth science students. And it was nice because honestly, I haven't had to actually teach any classes in a long time, and so kind of getting back into that, it was a really nice experience. It kind of reminded me of how much I like doing it. So that was pretty cool. Yeah, various events here and there, meeting various people in the university, meeting people visiting the university. Um, so yeah, lots to keep me busy in the last little while. Um, but definitely glad to be back and doing this.
Yeah, I was gonna say, because didn't you get to meet Steve Brusati at the
Yes.
university?
That's right. So yeah, Steve Brusati is a very well-known dinosaur paleontologist. He's currently at the University of Edinburgh, so far up north relative to me. Um, and yeah, I've actually kind of known Steve. Like the two of us have kind of known each other online for a while, although we haven't interacted too extensively. But yeah, recently, last month, in the middle of last month, was the first time we actually met in person, and it was really nice. He's definitely a very chill person to talk to. Very good speaker because he was here basically to give a talk about the recent books that he wrote. He wrote a recent book, the best-selling book even, on kind of his experience studying dinosaurs. It's called Rise and Fall of the Dinosaurs, and I think he had a new book come out more recently, even more recently, which is about the evolution of mammals, and he kind of combined both of those themes into a single talk. And yeah, it was quite good. Um, but yeah, that definitely really nice to be able to kind of make his acquaintance in in physical space at last.
Oh yeah. I definitely have. I haven't met Steve Brusati either, or really talked with him, but I'm definitely very familiar with him. I really enjoyed Rise and Fall of the Dinosaurs. I don't know if I relayed the story here on the show yet, but back when the National Museum of Natural History with the Smithsonian was finally opening their new fossil hall that was newly renovated and updated and very lovely done. I'd been planning this trip for a while. It just so happened that prior to leaving, when I went to the library, I found the audiobook version of Rise and Fall. And I was like, huh, I've been curious about this because I've been seeing it around and people have been giving, pretty good words about it. Um, and so I went and started listening to it. And then my old friend from college got caught wind of this trip and he wanted to come along. And I was like, yeah, sure. So we were driving and I was like, hey, do you mind if I continue this audiobook? He's like, oh, well, what is it? Oh, it's Steve Prasadi, Rise and Fall. And I explained it. He's like, oh, wow, I'd kind of like to see that from the beginning. I mean, we have a long drive ahead of us anyway. And I'm like, all right, sure. So I actually started it over the first couple of chapters
Wow.
and driving all the way to DC and then driving all the way back, we listened to the entire thing. Um, and we both really enjoyed it. And that's always just a fond memory of mine. So I kind of like to joke to myself that, well, if I ever come across the audiobook for the mammals one, that I would plan a big trip and then just listen to it as I drive.
Yeah, I guess before I forget, I should probably also mention that Steve Brasadi was the consultant on the most recent Jurassic World movie, so that's pretty cool.
Oh yeah, I really loved his recent tweet where he met with one of the discoverers or discoverer, I forget how big the group was of Pyroraptor,
Oh yeah,
which
that's
is
right.
a relatively obscure dromaeosaur. I want to say from Eastern Europe,
Yeah, France.
I think. France. Okay, so in the West. Um, but they were both actually pretty surprised that that animal got featured in the film, considering
Right,
how scrappy it is. But now it's a movie star, which is kind of fun.
right.
Um, of course, for us, Dino kids growing up, our Pyroraptor was the one from Dinosaur Planet,
Yeah.
the Discovery Channel, Pod's Travels, which, oh man, that's a fun memory that we could go into.
Oh yeah.
But we must move on, but not away from paleo documentary, certainly, because we have quite a bit of follow up regarding some shows that we've mentioned and a couple new surprises as well.
Mhm.
So, if you have, unless you have anything else to add, you want to go ahead and talk about those?
Yeah, let's move on to the next slide.
Sure. So, all right. First of all, we did mention a couple shows back. I don't know if this was the last show or the one before, um, that the BBC was working on a new dinosaur series called Dinosaur with Stephen Fry, one of the alumni from Monty Python, and also a big dino nerd himself. And we mentioned that that was coming and that it was going to be a four-part series that kind of looked at the latest science and dinosaur paleontology, the usual stuff. Um, so as of this recording, um, the first three out of the four episodes have already aired. And the show has featured a couple of paleontologists that are fairly well known, Susie Maidman, Dean Lomax, for example. But what's interesting is kind of the response that the documentary has been getting. Now, obviously, here we don't want to just play bash the dinosaur show, um, but just kind of based on what we've been seeing from across the paleo community who's been watching the show, um, it has not been what we've been expecting. Like it's there's a lot with it that is what's the right word to use? Very off.
Mhm.
Um, so right now on IMDb, the show has a 3.3 out of 10,
Oh my
uh,
goodness.
which is not very good. um, and while either of us have not really watched any of the episodes
Mhm.
yet, we have gotten kind of feedback from people who have close friends, paleo people, and they've noted that a lot of the imagery in the show is mainly stock models from video games that are interspersed with like the dinosaur models that were made specifically for the show,
Mhm.
um, and some very dodgy graphics and imagery. Now, to be fair, every dinosaur documentary can't have like a Jurassic World level budget,
Right.
in the billions of dollars. So like that's understandable. Um, but like in terms of the stock models, like it's almost as if they didn't really try. Like if you're familiar with video games like Ark Survival Evolved or Turok, you'll see models of the animals featured in those games as like kind of background uh, critters. Um, but like if you know those games, you know that those are some incredibly dodgy and highly stylized, uh, and otherwise very inaccurate um, models of real animals. Um, which is just kind of it just kind of throws you off if you pay attention to those sorts of things. Um, and there's also like very dodgy imagery with some skeletal depictions of some of the dinosaurs. Like
Mm.
they showed a couple of the large carnivorous dinosaurs, and like the musculature and like skull dimensions were all off. Even after they show like a photo of like an actual skull in a museum, so it's like, how did you miss that?
Right.
Um, but like so far as I can tell, like the research and like what they actually talk about the animals is fairly spot on and accurate. Like a lot of new stuff that has come out in the last couple of years. So I really don't know where to stand on this show. It's like they have the script for a really good dinosaur documentary, but there was almost nothing with the imagery, save for some of the models. And even then, some of the better models, or maybe a couple of years out of date, um, could have some work done on them. So overall, like the gist that I've been hearing is that it's been a big disappointment.
Mm.
Um, but I'm curious about your thoughts, Al.
Yeah, I mean, like you said, I haven't watched the show either, but I have pretty much the same impressions from the reactions I've been seeing. Yeah, like I've heard that most of the information seems good, but definitely the visuals aren't great. And I know, like, to be fair, some of the consultants have come out and mentioned that, yeah, because they didn't have much of a budget and were very short on time, so obviously they couldn't put a huge amount of effort into the a lot of the CGI components, but still, like, yeah, like getting stock models from video games. Yeah, that's still seems fairly dodgy for what is meant to be a scientifically credible project. Um, so yeah, it does seem like a bit of a shame, that's for sure.
Yeah, it's like it almost kind of shows that there should be more available and less costly resources for people, whether they're working on like a budget television show or otherwise, to have sort of like reasonably accurate stock models of prehistoric animals that are not like highly detailed and they can be kind of thrown in
Right.
um, like as they are in the show, but they actually like look like the animals that they're trying to portray. Um, like I know there's that one model maker, and he's recently passed away. I forget his name, but like his stuff is everywhere. Um, like I'm kind of surprised like those weren't available um, for use versus like video game assets, which I'm sure there had to be some legal things with that because like aren't like the arc survival of all the animals like copywritten designs that
Right.
are like with so like how did that I don't know how all that worked. So I'm very curious about it. Um, but at the very least, that is just one amongst a myriad of other paleo documentaries that we're getting news of that are up and coming. And a lot of those are certainly, have much higher expectations, just kind of based on previous output. So, so this is a very recent thing. Like we just put this in the episode at the last minute. We just got the announcement as of yesterday of this time of recording that Prehistoric Planet, the Apple TV Plus series hosted by David Attenborough and featuring the BBC Natural History Unit, is getting a season two. So we're going to get a bunch of new footage and new scenes with a host of what are no doubt going to be spectacularly designed and scientifically accurate dinosaurs and other creatures. They've already teased like Tarchia, for example. That's the image here on the top left. East Asian ankylosaur, and also like possibly a section in India with sauropod dinosaurs. So, and that's all that they've really shown. Like it's been very, very small snippets. But what's really surprising, or at least what was surprising at first, was that this is not so much an announcement for season two, like, oh, we're going to start working on season two. No, they already have a release date, and it's May 22nd. So just a few months away for a whole season of a show that, based on what we heard, took many years to develop,
Yep.
especially in terms of like the consultation work and the filming. So like at least for me, I was like, well, what's how did they manage that? Like, are they gonna power through this like an MCU film, which is like, ugh. But apparently, and like you've clarified some of this as well. Apparently, like they've been kind of working on this already, like as they were working on the first season, and they're mostly just kind of waiting for the right time. Is that accurate?
That at least seems to be my impression. Yeah, because obviously there's no way they could have started from scratch and put everything together in the space of a single year. So they had to have been working on this for a while, and I have reason to think that they have been. As you might recall, I loved the first season. So yeah, this is really really exciting.
Oh yeah, and me as well. I mean, uh, without getting into too many details, the first prehistoric planet like came out at like the perfect time for me mentally.
Hmm.
Like it was a breath of fresh air and it was a very welcome thing. And I just fell in love with how they did the show. Because like for those of you who are not in the know, it is very much like the more recent BBC Landmark Natural History series, where they focus on different environments and they go from place to place around the globe. But with Prehistoric Planet, they dedicated the entire series to just a single span of time. They dedicated the entire show to depicting a single age in the late Cretaceous, the Maastrichtian. And they just hop from around the world to just kind of emphasize that, hey, even in prehistoric times, the world is a very diverse place as it is today. And there's regional variation among so many different habitats and ecosystems. Um, and it was just very well done. And the CGI is top notch. Like it's probably some of the best models that I've seen for prehistoric animals,
Oh,
like not in film, in a very long time. Some of those shots, you could swear that they were real animals. That's how good it was. So I'm very much looking forward to this. Apparently, Mark Whitten has come forward, the paleo artist and paleontologist who's focused a lot with pterosaurs. Um, he's mentioned that he's had to design some of the most like bizarre critters he's ever seen. So what does that mean? I don't know.
yeah.
Um, that's going to be really exciting. So yeah, May 22nd. So that's just around the corner. So you'll probably hear about it from us, no doubt, and also everywhere if you're in the paleo community, because my goodness, the first one got some traction. Um, we have a couple other projects as well that we want to highlight, because I don't believe we mentioned this in full the first time, but Netflix has jumped into the game with natural history documentaries. They were the ones who did Our Planet, which was the David Attenborough series, where they again looked at different habitats and they focused a lot on the conservation aspects of those habitats. They started ordering more series that are, I guess, in the same franchise because like they're all very similar in titles.
Right, right.
Um, and so for this one, we have Life on Our Planet. Now this one, despite Our Planet being a David Attenborough series, this is not he is not involved in a lot of these newer ones. This time they got Morgan Freeman, another famous voice in the world of media, and he's going to narrate this series. Now already they've dropped other shows in this sort of vein. Like just recently, Our Universe was dropped on Netflix, and I've actually been watching some of those. So I kind of have an idea, I think, for how life on our planet is going to go. Because as you can imagine, Our Universe deals with cosmic topics, but also kind of relates it to the Earth. So it kind of shows like Earth systems and cosmic phenomena are intertwined, and a lot of very beautiful footage of charismatic wildlife, cheetahs and penguins and chimpanzees, the usual. Um, but also mixed with like very beautiful like CGI footage of like space and black holes and galaxies and all this stuff. So it's really cool. Um, but the general vibe is very chill and relaxing. Like it's almost kind of like a calming experience to sit through an episode. Like, oh, if you're over anxious or um, you're overwhelmed, just sit down and watch an episode of Our Universe, and you're gonna be smooth by the end of it. Because of course it's Morgan Freeman. Like, come on, like his voice is he has that effect on you. So life on our planet deals with geologic time. Now they haven't really announced what the angle is on the show, like what sort of crux is holding all of the episodes together. There are 8 of them that they've announced. And based on the teasers that we've seen, we have hadrosaurs and tyrannosaurs, probably Tyrannosaurus itself, which is, you got to have T-Rex in your documentary, I guess. But also things like Arthroplura, the giant millipede relative, saber-toothed cats and terror birds in the Pleistocene of South America. So it's a very diverse bunch, and so they're probably going to do like a trip through time sort of thing. Um, Now, this series is coming this year, but to my knowledge, they still have not released an actual date yet. But considering that Our Universe had just dropped, and there were like 2 other series that they were going to do as well, um, it's probably not going to be a long wait. But we'll definitely be there to let you all know when that comes out. So definitely keep an eye out for that. That looks really cool. Um, and also, we did hint that Tim Haines, the director and producer of Walking with Dinosaurs, a very beloved and well-known classic paleo doc, was gonna helm a project for NBC, and so now we have many more details about that now. This is Surviving Earth, which is represented by the image at the bottom left of the very terrified dinosaurs running from the doom. Um, but this one uh, touches on mass extinction events and sort of like the great ages of transition in the history of life. And much like Life on Our Planet, there are 8 episodes, and they're also an hour long each. So a lot of paleo uh, between the episodes, which I think was like even longer than what Walking with Dinosaurs had done, because those were about 30 to 40 minutes, if I remember correctly.
Yeah.
Um, so with this one, Tim Haynes is the showrunner and creative director, and production, that is filming in certain locations in this case, actually began last month in February. But they've been working on this for many years. So it seems like that is coming along just fine. And apparently, they're also going back to some locations where they filmed the original Walking with Dinosaurs, like New Caledonia, which has a lot of very unique flora that is conducive to making a Mesozoic piece. So that's kind of exciting to see. In terms of like what kind of stories they're going to feature, like what episodes might be included in this panoply of mass extinctions. Um, they have confirmed that the Great Dying, the Permio-Triassic extinction, is going to have an episode. Of course, as the image here might suggest, the end Cretaceous extinction is going to have one. But one that I was very curious about was apparently they're going to feature the Younger Dryas as an episode.
Right.
Quotes a mammoth flood just 12,000 years ago that plunged the planet back into an ice age, which is what the Younger Dryas was. The glacial melt in North America pooled into the Atlantic and shut off the conveyor belt systems in the ocean that brought back the glacial conditions that had just been coming down. So it was like it's cold, and then it's slowly getting warm, and then boom, cold again. And this has been talked about and discussed in the literature for a while regarding to its impacts on megafauna and human communities at the time, because people had been settling in the Americas, and there's a lot of back and forth about, well, the Clovis culture, which is a North American phenomena with similar stone tools across the continent, maybe the loss of that culture is tied to the Younger Dryas, and that's more or less been kind of debunked. So I'm very curious as to what they're going to try to do with this, because so far as I've been able to tell, the Younger Dryas was not a mass extinction event. And there's even some evidence to suggest that it wasn't as bad as earlier studies suggested, even in places like the Middle East, where it's been tied to the loss of the Natufian cultures, the proto-farmers. So I don't know. I severely hope that they do not try to put in that Younger Dryas impact hypothesis that is near universally panned among archaeologists and geologists. The evidence for that is not very strong, and to date there is no crater that's been found. But then again, according to the model, the crater, well, the bolide hit a glacier, and then the glacier melted, so then no more crater. But it's like, well, hang on a second, that's kind of dodgy. So I'm hoping not, because people have tried to take that and like, oh, well, that's why the Clovis culture and all the megafauna died out. A comet hit the Earth and just destroyed everything, or at least made things really bad. But I don't know. Tim Haynes is usually pretty like the whole Walking with Dinosaurs franchise is usually pretty good with their science, even if they will exaggerate the sizes of animals, for example. That's such a minor thing. So I don't think they're going to do that, but I'm hoping that they don't do that. Please don't do that. But I guess we'll see. This is going to air again on NBC, and also have it available for streaming on Peacock, which is NBC's Netflix streaming service thing. But to date, we have no premiere. But I'm getting kind of ahead of ourselves here. Did you have any thoughts, by the way, on life on our planet or surviving Earth?
Not much that you haven't already mentioned. Yeah, like you said, we don't have a whole lot of information about these shows yet. We just know they're coming and their basic premises. So yeah, they do look promising from what we've seen so far. So I'm looking forward to them. But otherwise, yeah, no, I think you covered them pretty well.
Okay, cool. Well, we do have at least one more that we'll mention before we move on with the last of our shout outs. Forgotten Bloodlines Agate is a project that's been kind of up in the air in the paleo community for at least the past year or so, if I recall. This is an independent production directed by Max Bellomio, who the paleo community will know as Digital Duck on Twitter. This is a project spanning three 15-minute episodes about animals of the agate fossil beds in Nebraska dating to the early Miocene period, so roughly 20 million years ago in that span. So it's a paleo documentary that they've been working on that features relatively obscure animals in popular culture for paleo because if you're interested in this sort of thing, you'll be familiar with like the entelodonts, the so-called hell pigs, even though they weren't pigs,
Right.
like Daeodon, as well as the calicotheres, a type of odd-toed hoof mammal related to horses and rhinos, like Moropus, where the hooves have turned into claws. And so it kind of looks like a cross between a gorilla and a panda and a horse, and it's a weird mix of critters. Um, but they're very fascinating animals, and like the world that they lived in was populated by strange mammals and birds and really cool things, and in North America nonetheless. So it's part of the heritage of this continent.
Yep.
So it's kind of nice to see that they've been working on this project to kind of give those animals uh, some more spotlight, so to speak,
Yep.
because there's a lot of interesting history there. What's also kind of cool was they managed to bring Nigel Marvin to be the narrator. Now, if you don't know Nigel Marvin, he's a zoologist and he's very big in TV, at least in the UK,
Yep.
where he does a lot of shows where he like goes on cruises and goes around the world to various countries and he gets to explore the wildlife of those areas. Um, and he's always been like such a chill guy. Like he's in the vein of like Jeff Corwin and Steve Irwin, where he's out in nature and he's showing you the animals and how cool they are, and it gets you excited, and you want to learn more about them because they're so cool. Um, and Nigel Marvin has a foot in the door of paleontology for many years now
Yep.
because he was the host of a number of series in the Walking with Dinosaurs franchise, particularly Chased by Dinosaurs and Chased by Sea Monsters, which basically were series where he goes back in time and like in search for specific animals. Um, so in the case of like Chased by Dinosaurs, he's looking at like two weird fossil organisms that are very curious to him. So like Argentinosaurus, the large sauropod, probably one of the biggest, and Therizinosaurus, which is a theropod with very long clawed fingers that was very big and not what you would think when you picture a theropod. Very derived anatomy. And then Chased by Sea Monsters was like the top 8 deadliest seas of all time or something like that.
Yeah.
Um, and he featured, like mosasaurs and basilosaurus, the whale, and sea scorpions, and all kinds of really cool things. And also, he was the host of Prehistoric Planet, which is no, damn it, he was the host of Prehistoric Park.
Yeah.
A lot of prehistorics in
Yeah.
media, um, which was also a really fun show. Where basically it's like, what if Jurassic Park, but like nothing went to shit. Like everything went really well, and it was also like a really fun experience. Um, which is kind of funny that because no spoilers, things kind of go off the rails by the last episode, but
Yeah.
it all works out in the end.
Right.
Like nobody dies.
Yeah.
It's a it's a really fun experience, and it's been so long since I've seen it too. Um, so to kind of see him back in paleo narrating the series in a very charismatic Nigel Marvin way is a treat. Um, Now the thing about Forgotten Bloodlines that we must stress, this is not like, oh, it's going to be released on June 10th. Brace yourselves for it.
Mm-hmm.
They've actually just launched a Kickstarter
Yep.
because while they've been working on this series for a number of months, uh, they still need funds to like finish up production and like actually get things going. So right now they have a Kickstarter for $75,000 to finish the first episode. That way, that can be released, and they can maybe do another one of these for the next couple of episodes. Um, but they do have stretch goals. So if those stretch goals are met, where additional funds are provided, they can do all 3 episodes and put them out in a timely manner.
Mm-hmm.
So that way, Forgotten Bloodlines can see the light of day. Um, and right now, at the last I checked, they are over $29,000,
All
and they
right.
have until March 23rd to be fully funded, at least for the main goal of that first episode. So like it's been climbing. Like just a couple days ago, it was like $22,000. So it's coming. But this is such a fun and great and important project, and I would like to see it
Mhm.
see the light of day. So we'll definitely link the Kickstarter in the description if you are interested in helping out, or at least like learning about what the project is and like tell your friends, tell your fellow paleo nerds, um, because it looks really cool, and I'm very impressed with the cinematography and the models of the animals. They look very good, and they put a lot of work into getting them as accurate as possible, especially the entelodonts, which is an animal that's very easy to over exaggerate in art.
Yeah.
But we don't have time to get into that. Albert, do you have anything to add about Forgotten Bloodlines?
I mean, I'll stress again that this is not a project that's being backed by a major studio or company or anything like that. This is an actual like independent project that was basically put together by a bunch of people who are interested in paleontology and had the right skills to like make something like this. Um, so it's incredibly impressive in that regard, and I really hope that they achieve their goals. And like you kind of alluded to, they have already released like little teaser clips and such of what they currently have, and it definitely looks incredibly impressive, especially in light of how it was produced. Um, so uh, I I definitely hope that they manage to bring this project to completion, and we definitely will add some links in the description to the fundraiser, so everyone listening to this before the deadline at least can contribute. And yeah, it is really cool that they decide to highlight such an obscure fauna in prehistoric times, because there were some really weird and impressive animals that lived in that fauna, and they are essentially unknown to most of the general public. So yeah, excellent choice. um,
Yeah, like I think this is like technically the first. Well, this would be like the first independently produced paleo documentary
yeah,
series, wouldn't it?
I think so. Yeah. Um,
Because the Dinosauria was more of an artistic uh,
right.
um, uh, endeavor.
That's true.
Yeah, like this one is like an actual like documentary, like with a narrator explaining the animals and the
Right.
science, and I'm pretty sure that's the case.
Yeah,
Um,
that would be my impression too. And um, yeah, it's really is incredible. Like it's hard to understate how incredible like a project like this can actually happen in these days. Because I definitely know people have joked about like people in the paleo kind of I guess enthusiast community have joked about like like most of the documentaries that have come out about paleo uh, in the last you know I want to say few years, but it's probably like over a decade by this point. Um, haven't really kind of met our standards like scientifically or even just in terms of the general presentation. Um, and people have joked about, oh, we should just come together and make our own documentary. And, and I'll stress also that a lot of these discussions were happening before Prehistoric Planet came out. Of course, well, once Prehistoric Planet did come out, it was largely universally acclaimed. But yeah, this was before we had anything as good as that, at least not since the original Walking with Dinosaurs. And so yeah, people have joked about let's just make our own documentary, and of course it would people would kind of get really excited about all the ideas they had, but just not actually go ahead and do it because there are all kinds of barriers to actually making a documentary, as you can imagine. It's all very well to come up with ideas, but yeah, like having the skills and the time and the energy to do it is a whole other matter. But here we go. It actually can be done. Like this is something that's actually happening, and it will happen if they receive the right support from everybody. So yeah, this is really cool. That's really I think my takeaway here.
yeah, totally. So like we got a lot of really exciting paleo projects to look forward to in the near future. Um, Considering like how great last year was in terms of paleo, that we get another year with more great paleo. Like it's we're eating good tonight, as our friends have been saying. Um, so definitely excited for all these projects and more, because there are certainly other things that we don't have time to go into. Um, but yeah, state of paleo documentaries right now, pretty good, I'd say. But yes, we must move on. But in sticking with the kind of Cenozoic theme, so in our last episode, we discussed a very important paper by Kurt H. Kier and colleagues, in which they were able to extract environmental DNA from ancient samples from the early Pleistocene of Greenland. That was around 2 million years ago. And of course, this revealed a remarkable and unfamiliar type of ecosystem populated by a mix of present day Arctic and boreal forest wildlife in a local climate that was warmer than this area of Greenland is today. Now, in the accompanying articles for this study, paleoartist Beth Zeiken has produced this very beautiful piece that showcases kind of an idea of what this landscape looked like and what types of plants and animals were discovered in the DNA samples. Now, I had messaged her about using this artwork for our episode, but unfortunately, the timing was off and we weren't really able to use it, such as happens with projects like this. It's no big deal. Um, Beth Zeiken was very gracious enough to allow us to use this image anyway, and so we're going to follow up with it here now. Now, in the piece, you can see very clearly the kind of combination of conifers, birches, poplars, and willow trees there in the background, um, and which are many genera of trees that obviously don't grow in Greenland today, but they are found in the boreal forests of North America and Eurasia. In the foreground, amidst the grassy slopes, we see horsetails and a really nice little patch of avon flowers on the left. And of course, we have the mastodons of the genus Mammoth, which feature prominently here in the middle. But we also see a nice flock of geese and some reindeer in the far right. And you can see sort of an Arctic hare with kind of the summer coat and a vole type rodent to the bottom right. So, yeah, this piece is very lovely. And I mean, we can't thank Beth Zeiken enough for allowing us to share it here. Now, if you wish to have this as a framed or canvas print, or even as like a pillow or a clock, she does have it available for sale. And much like the Kickstarter we mentioned, we will also put the links for these in the description as well. So we encourage you to go check those out. And if you like, go give Beth Zeiken your support. Do you have any thoughts to add about this piece, Al?
Oh, not much, but Beth Zeiken's work is always incredible, and the fact that this particular piece was based, so heavily on an incredibly detailed study is the icing on the cake.
Oh yeah, like I've seen some of her work on Twitter. 'Cause she does like murals for museums
Right.
and institutions. Oh my gosh. Like it's those types of like paleo murals where they're just so immersive. You just want to jump in and look at every little detail,
Yeah, yeah.
and like all the details are as accurate as you can be. So it's just a really great snapshot of the past. So it's really cool to see that she had contributed to this paper as well, which again was such a landmark study that is really going to change a lot of things in terms of environmental DNA studies. So very happy. Thank you again, Beth, for letting us use this. Um, but with that, we can move on to our stories. Now, I will mention, and we jump to the next slide, um, kind of bringing back a classic aspect of the show that I haven't really done in a while, mini book reviews. Some of you may remember that I've talked about um, like Rutger Bregman's book Humankind in the past as like a new story for the show. There are two books here that I read in the past month that I just adored, and when I finished them both, I knew that I had to talk about them here on the show. So I'm going to take the opportunity now to do just that. So first up, The Last Days of the Dinosaurs by Riley Black. This is the newest of the two books that I'm going to talk about today. This was released only in April of last year. Now, Riley Black is a well-known paleontologist and author whose work I've personally followed for many years. her earlier books, including Written in Stone and My Beloved Brontosaurus, were very influential to me. I believe I read them in like late high school and freshman year of college, just kind of based on like the timing of the books. Um, and like they not only gave me some idea of the then current understanding in paleontology that I was looking for, they provided yet another example of an author who knew how to bring forth so much information and yet fold it into a very clearly and frankly beautifully written text. And so that sold me. And Riley Black became one of my favorite authors in paleontology. So, with her announcements of the last days of the dinosaurs, I was really excited. And the book came out, and more reviews came in. I was even more excited. And so by the time I was able to actually buy the book, I wanted to start it immediately. And I think I ended up spending only a week on it, which is a pretty good sign on my part. Hey, I enjoyed this book so much, I devoured it like I devour chicken wings. So, what is this book about? Well, in the simplest terms, it's an account of the end Cretaceous mass extinction event and its impacts on living organisms over time, from within the first hour of impact and on into the next million years. So the book isn't just about the last days of the dinosaurs, because within the first month of the impact, all the non-avian dinosaurs die out. And we spend more time with other reptile groups and mammals and insects and plants. So the primary focus of the book is on life itself, not just dinosaurs. And I think that's one of the strong points of the book. There's still this notion in popular culture that, oh, the dinosaurs and other big reptiles died out in the extinction event, and the small mammals survived, and then they proliferated, and that was that. But there's actually a whole lot of nuance in discussing the KPG extinction event. And Riley Black explains all of that very clearly. For example, in one instance in the book, she shows how some of the mammal groups, like the multituberculates, which are represented by a genus known as Mesodma in the book, they did survive the extinction, but they would end up not making it into the present day, because in some parts of the world, while they held on to their niches, in others you have the early relatives of rodents evolving, like in Eurasia, and these would kind of slip away the kind of slate for the multituberculates to kind of take over their niches and replace them. Um, and so it goes with other types of organisms, even the dinosaurs themselves, because remember, some birds, and I mean that some birds, not all the birds, would survive and go on to, colonize the skies and seas and land of the world today. And so, like, it really kind of shows that it wasn't just a yes or no flip of the coin with the extinction event. Like there's nuances here with different groups of organisms and how they survived. And with all of the groups that made it through, there were still losses. And what I really love is that before discussing the survival situation with each type of organism, she does spend some time clarifying just what they are and how they would have lived and behaved and how they're related to other organisms. And it really helps kind of familiarize the reader with some, very remarkable animals and plants. You can't talk about the story of the multituberculates without explaining, well, what the heck is a multituberculate anyway? Never heard of that before. So I really appreciate that. And as these examples show, Riley Black emphasizes there really is nothing in an organism's biology that makes them any less or more susceptible to extinction. It mostly comes down to chance. Even with the hindsight that we have based on all of the previous work and understanding deep time, we should recognize that there was really nothing inevitable about the losses and saves from the extinction event. Just because we don't have tyrannosaurs or hadrosaurs today doesn't mean that their extinction was inevitable. Their deaths were not required to create the living global biosphere. They just died out when the conditions became too much for them to handle. There's no like checklist that all these things have to happen in order to bring us to the present day, and then just set that in motion deep in the past. Um, so when we look at the KPG mass extinction event, we should really understand it as a random, very bad day in the history of the Earth that just so happened to pave the way for our modern world. And indeed, as Riley Black explains, the sheer chance collection of factors that went into this impact really made it even more worse than it could have possibly been. Everything from how it landed to what type of rocks were in the crust, where it hit. Um, it wasn't terrible enough to wipe out all life on Earth, but it wasn't a simple asteroid hits the Earth, things go boom scenario either. There's a whole long sequence of events. And again, these are explained very beautifully in the book. Um, yeah, so there's a lot of heart that's really put into the last days of the dinosaurs. Riley Black, like many of us in the natural history world, and certainly many of our viewers as well, you know, loves and appreciates the diversity and history of life on Earth. And she does not shy away from that aspect at all, which I enjoy immensely. It makes it more fun. And it's also a much more personal reflection on her own life journey as well. I'll just say, as a fellow trans woman, I felt a lot of empathy, as well as excitement and fascination alongside her. And a book that makes me feel that way is one I would highly recommend. So before I move on to the second book, Albert, did you have anything you wanted to add?
Not much, mostly because I haven't read this book yet, but I am familiar with Riley's work in general, and I agree that she's done an excellent job of, um, you know, communicating the science of paleontology and other topics too, to the general audience. So I definitely look forward to checking out eventually, whenever that might be.
Oh yeah, and I mean, I still have a very fond memory from college where how sometimes you go to grocery stores and they have like the National Geographics up in the registers,
Hmm.
and usually it's like a special issue that they put out different topics. Well, they had one on dinosaurs, and here you are thinking, oh, here we go. It's probably just going to be a rehash of like the previous National
Right.
Geographic stuff. Maybe like they got an author who doesn't really put in a lot of effort into it. But when I heard that Riley Black was responsible for the text in that, I immediately went and got it. And even today, like it's almost like a mini book more than a magazine, like the way that it's written, and it very clearly and concisely described the Mesozoic world and ended on a really great note, emphasizing, like many paleontologists are doing nowadays, that when we talk about, the story of the dinosaurs, it's really our story as well, because mammals evolved at about the same time as the dinosaurs. So we've gone through the whole roller coaster together. And to really understand, kind of our place in the world, we really need to include the dinosaurs and, their contemporaries in the story. Um, so I just love things like that. And I always think about how important it is to, to have an author who really knows what they're talking about and have like that passion and clarity too, to write books like this. And so I'm very glad that we have Riley Black to do that for us, among many others as well, including Patrick Roberts, who we have our next book here, Jungle. This came out in July of 2021. The subtitle here, How Tropical Forests Shaped the World and Us. So Patrick Roberts is an archaeologist who works at the Max Planck Institute for the Science of Human History. And he's also a National Geographic explorer, which is a pretty big title. So right away, while this book does define and explain what tropical forests are and their general natural history, including through deep time, Jungle focuses mainly on the relationship between human history and the tropical forests. Traditionally, archaeologists have tended to understand these environments as not very conductive to complex human societies, that they're the hub of mainly hunter gatherers or simple horticulturalists, and that their soils and climate were not capable of supporting the sorts of large scale urban environments known along, say, riverways and shorelines like in the Fertile Crescent or in East Asia. But in the last couple decades, new techniques and research have really turned this upside down. And Patrick Roberts spends much of the book showing this evidence. Now, somebody like me who's super fascinated by these sorts of things, uh, you know, that was one of my main reasons for wanting to read the book. And it was nice to know that, a book had just come out that could synthesize all this new data that had just been coming in. And it does, and then some. Patrick Roberts explores not just the tropical origins of hominids like Ardipithecus ramidus. He also effectively shows that rainforests were not the barrier to early Homo sapiens and their dispersals around the world that has been previously thought. People were inhabiting rainforests at a very early date. And he also explores how different peoples have settled on tropical islands. So we get like these stories of the Polynesians in the Pacific and in Madagascar and the Caribbean and even the Canary Islands. And he shows how agriculture was not only possible in tropical forests, they were used so effectively that for the most part, they were actually able to retain much of the biodiversity that those forests are so well regarded for today. And of course, the descriptions of the new research on societies like the classic Maya and the Amazonians and the Khmers, especially with all the LiDAR technology that we've been seeing to reveal just how massive these urban environments were, that was all amazing and very well done. But I think the aspect of the book that I enjoyed and appreciated the most was its tie-ins with sociology.
Hmm.
To be completely honest, I have never before seen a book of this sort that combines not just natural and human history, but also dives so deeply and honestly with questions about colonialism
Hmm.
and racial injustice and overconsumption in an environmental context. I mean, the way that Patrick Roberts outlines the last 600 years of European colonialism, from the conquest of the Canaries to the neo-colonial powers of mega corporations that are just strangling the life out of rainforest peoples, is very expertly and effectively done. I've seen a lot of discussion about modern conservation movements, for example, and how they're also tied into this web, for better or for worse. Especially in the case of like people, you have people that talk about, oh, we need to empty endangered landscapes of people so we can preserve them, which is not the way to go. And so he does not shy away from that either. He lines out how these issues are all tied into the Anthropocene event. And yes, he uses that as an event, not an epoch. What has happened, what is happening, and how it's being dealt with right now, and what more can be done. And I think his arguments, which are of course are based on so many others who have worked in this field, are pretty fair, and they do actually line up a lot with talking points that you and I have made
Hmm.
in previous episodes of the show. So I was very pleased to see that, and I highly encourage more authors, and I'm sure they're out there. I mean, there's so many books in the world
Yeah.
that I'm still discovering. But I really hope that more authors do this sort of thing, um, because really, like a lot of these issues, whether you would think that they weren't connected at all, are actually very deeply ingrained. Just certainly relevant for a lot of like the paleo community, for example, where you have folks who complain about politics getting into things when no, there's a very important reason why we're bringing these things up in the field. Um, so yeah, if you're interested in the nuances of the end Cretaceous mass extinction event, or how humans and their ancestors have coexisted with tropical forests, I couldn't recommend these two books enough. You we still don't have a formal ranking system yet, so if I'm gonna just go on a 5-star model, I mean they're both 5 stars,
Hmm.
easy. Um, Albert, do you have any more comments before we continue on?
Uh, Nothing of substance really, but I wasn't familiar with this book before, but it sounds absolutely fascinating, and yeah, that does sound like a very commendable approach to have taken. So I will have to put it on my radar.
Yeah, absolutely. It's a pretty breezy read too. Patrick Roberts is another one of these authors who knows how to weave stories together and kind of keep you going along the ride and keeping things very clear too.
Yeah.
Um, which I always appreciate, especially if I know that people who are not as deep into these subjects as I am are going to pick up these books and hopefully they'll learn and maybe start their own journeys into these sorts of fields. Um, so yeah, definitely very very happy with these. I'm glad I could talk about them. today.
All right. So I suppose we can go on to our next story, which is my first story of this episode. So my stories in this episode are going to be a kind of more traditional approach that we've taken, where it's like um, discussing new scientific papers that have come out in fields that we are interested in. And so this first paper I'm going to talk about is certainly one that I have a strong interest in. Um, so I work on bird phylogenetics, and here is a study on bird phylogenetics. Um, but since it is not, it doesn't deal so much with kind of the paleontological aspect of things or sort of deep time evolution, at least that's not its main focus. Uh, I figured I would not include it as a part of an update special to Dinosaurs, the second chapter, but instead just kind of talk about it in one of our regular news episodes. And so this is a new study on the phylogeny of herons. And I think most people in the world are likely to be familiar with herons to some extent. They are pretty common across most of the world, unless you live somewhere close to the poles or in the middle of a desert. It's quite likely that you have one or more heron species living near where you are. And many herons are quite big and conspicuous birds, and they're not super wary of people. I mean, obviously, most of them will fly away if you get too close, but a lot of them will just stand out in the open and let you observe them for a long time without being too bothered. So, yeah, I think herons are a group of birds that most people will probably take notice of at some point. If you live in North America, for example, across most of North America, you can see the great blue heron, usually standing very conspicuously in water bodies. But you can also find herons that are, in places that aren't, immediately next to water necessarily. And in the here in England, our most familiar heron is the grey heron, which is a very close relative to the great blue heron, and looks very similar. But yeah, like I was saying, some herons do wander away from water quite a bit, and in fact, even something like the great blue heron, you can sometimes find them out in open fields, for example, where they hunt things like rodents and such, out out in the grass, and that brings us to another point about herons is that they are quite incredible predatory birds. Kind of everything about a heron is made for kind of thrusting that face forward like a harpoon, and it's basically shaped like a huge harpoon. Well, okay, relative to an actual harpoon, it's not huge, but for the size of the bird, the face is pretty much built to kind of stab and capture prey, and they in general, most herons feed primarily on fish, but not exclusively. They'll hunt other aquatic animals, things like, crustaceans, frogs, and other amphibians. And they'll sometimes hunt animals on land as well, small mammals, you know, lizards and other types of small reptiles, and they'll hunt other birds too, like small birds. They'll kind of if a small bird gets too close to a heron while it's just standing there, there's a non-zero chance it would just dart out and grab it straight out of the air. So yeah, they're not too picky. Pretty much anything that can be swallowed, any animal that can potentially be swallowed by a heron is a potential prey item to them. And since many of them get pretty big, that kind of opens up the kind of diversity of things they can eat quite by quite a fair amount. And like I said, herons are often pretty easy to observe, and sometimes they'll gather in big flocks in the trees, for example. They like to gather in big flocks to rest, and also to build nests. So they'll often nest in these big colonies in the trees. So if you have a kind of heron rookery, as we call them, near where you are, yeah, you can kind of see that in action. There are some herons that are a bit more secretive and not so conspicuous too, but definitely there are many species of herons that you can just go out to like any body of water near you, and sometimes not even to a water body, and just see them doing their thing. So that's really cool. Now you might think that herons, being such a familiar group of birds, we would have a really good understanding of like all aspects of their biology, but that is not really true. I have to say, like relative to how familiar herons are, I think they're a relatively understudied group, and that includes like their phylogeny, so how the different species or major groups of herons are related to each other. Um, Up until this new study, uh, there hadn't been too much work done on the subject. There had been some, but many of the previous studies on heron phylogeny didn't include like a wide variety of species, or they did not sample large components of the genome. So they might have looked at just a few genes or something like that and tried to reconstruct the phylogeny. And certainly that's better than nothing. But in this day and age, when it is possible to sequence like huge amounts of genetic data, we often like to see like kind of more comprehensive studies about the phylogeny of different organisms. And that's basically what this study did. So they basically reconstructed the most complete phylogenetic, or the most complete phylogeny of herons that has been done to date. They looked at 55 species of herons, and there are over 60 living species of herons around, and the exact number depends on how much you count them, but either way, that's over 90% of all living heron species that they included in the study, and sampled genes from all across the genome. So these weren't like complete genomes, but they took like large parts of across the entire genome to reconstruct this phylogeny. So it's definitely kind of the most detailed look at heron phylogeny that we have so far. So this is the figure from their paper of the phylogeny they think is best supported by their data. But this might be a little hard to read on this slide. So on the next slide, we can kind of break it down a little bit. And now you can meet all the different major groups of herons. So what did they find here? So essentially what they found was that they found a group called the tiger herons, which are a group that live in the tropical Americas, are the sister group, so the closest living relatives to all the other species of herons. So in the modern heron family tree, the first split that happened in this lineage was between the tiger herons versus everyone else. And they're called tiger herons because they often have this kind of striped pattern on their plumage. You can maybe kind of make it out in the photo here. So yeah, they're quite impressive looking. And then as we go to the lineage that leads to everybody else, then we get to the next split, and this one happens between another tropical American species. And in fact, this lineage only has a single living species. It's called the boat-billed heron, and this one might be probably the weirdest looking heron of all, because if you can make it out from the photo, the boat-billed heron does not have a beak that looks like the beak of any other heron species. Like I mentioned earlier that a typical heron kind of has a beak that looks like a harpoon or a spear, but a boat-billed heron has this really wide bill that's very strange. Apparently it uses this bill as a sort of scoop, so it kind of scoops up things like crustaceans and fish in the water. So yeah, very, very odd. I've seen this species in zoos, and they're always an interesting sight. So yeah, quite an unusual heron, and it's kind of appropriate then that it's kind of standing out in a lineage just by itself. And then we continue to the next split, and this is between yet another tropical American species. So the authors of this study did not do like kind of any ancestral state reconstruction of like trying to estimate where these different lineages originated. But if I had to guess, I guess the tropical Americas must be like a kind of major center of diversification for herons, because you can see that all these like first few splits, these oldest splits in the tree, all lead to like tropical American lineages. So that seems fairly likely to me. In any case, the next split leads to another tropical American species, and again, this lineage only has one living species called the agami heron. The name agami apparently comes from an indigenous name for this particular species, and it's an amazing looking heron. I don't know if you can make it out from the photo, but it's got this really interesting color pattern. Like arguably, it's the most beautiful heron in the world. So I think looking at this tiny thumbnail on this slide does not really do it justice. You should go look up pictures of agami heron if you haven't seen pictures of them already, or seen them in person if you're lucky. It's a really, really cool looking species. And then we get to the next split in the tree, and now from everything here onward are mostly more widely distributed herons. So these are herons that got out of the tropical Americas. And so here we see a divide between the bitterns versus everyone else. So the bitterns are a group of herons that are one of the more secretive groups that I kind of alluded to earlier. A lot of bitterns have like very kind of cryptic plumage, like usually shades of brown and kind of with these streaky patterns and such. And they like to stay hidden in waterside vegetation. If you look up pictures of them, you might be able to see how some of them have this really distinctive hiding posture. They'll kind of tilt their head upwards so the beak points up, and then combined with the sort of striping pattern, they can blend in very well with the reeds that they like to hide in. So they're a difficult group of birds to see. Um, yeah, I've seen a few of the smaller species of bitterns, but I've never seen, for example, the either the American bittern or the Eurasian bittern, which are the two big species that I've been like in range of. Yeah, very interesting group of herons. Um, and then next up, we come to another split between the forest night herons and the rest. So the forest night herons are a group that you are most likely not familiar with. So this consists of two species from Asia. Now, there there is one instance where you might be familiar with forest night herons, and that is if you have lived in Taiwan, like I have. And this is because one of the species, the Malayan night heron, um, is a very easy bird to see in Taiwan, which is very interesting because it is not only found in Taiwan, but in other parts of its range, it's actually known as a very difficult bird to see. It hides a lot. But in Taiwan, for some reason, and this is something that's happened in the last few decades, like when my parents were little, this is not the case. But nowadays, if you go to Taiwan and you just go into city parks and such, you can see these Malayan night herons just wandering out in the grass, or just hanging out, or like hunting for earthworms and insects. And they even nest in the city parks and such. Sometimes you'll see big nests in the trees. And at night you can hear their kind of booming calls, and it's really cool. It's a really interesting, species of urban wildlife to see. But yeah, the ecology of a lot of Taiwanese birds is very understudied. So I'm not sure if we know why they've suddenly become like so abundant and so common in urban regions in recent times. But yeah, this is a lineage of herons that I've been lucky enough to see, whereas most people haven't. Next, we come to kind of the group of, I guess we can consider more typical herons that you imagine when you think of the word heron. And so the deepest split in this part of the tree is between what I label here as kind of mid-sized typical herons. And so this is a pretty diverse group that kind of includes a bunch of, like, as said on here, like herons are kind of medium-sized for the group. They include a lot of the species of herons that we call egrets. Kind of phylogenetically, there is no real distinction between an egret and a heron. Most of the time, the name egret just gets applied to the species that happen to be kind of mostly white in color. So things like the little egret and snowy egret, they are members of this mid-sized typical heron lineage. But there are all kinds of other herons in this group too. And the white-faced heron of Australia, things like the tricolored heron in the Americas, the black heron in Africa, which is known from kind of using its wings. It'll spread its wings to create shade on the water to attract fish. Fish will come, oh, look, here's some shade, let's hide there. And then, oops, it's something that wants to eat them. The mid-sized typical herons are a pretty diverse bunch, and it's quite likely that in most parts of the world you'll be familiar with at least a few species of them. And then next up, we have a division between the night herons, the true night herons. So these are distinct from the forest night herons that I mentioned earlier. As you can tell from the name, some types of herons are primarily nocturnal. They mostly feed at night. But that's not to say you can't see them around during the day. It's just that they're a bit more active at night. And so, the night herons are another group that you are likely to be familiar with no matter where you live. Certainly in North America, for example, I know that the National Zoo in Washington, D.C. is a place where during the summertime, like big groups of black-crowned night herons come and just nest in the trees there. So that's a pretty good opportunity to see not only zoo animals, but also these wild night herons. And in fact, to kind of stop the night herons from competing with the zoo birds for their food. The zoo actually started feeding the night herons as well, so that's pretty cool. They when I know it's been a while since the kind of bird area of the zoo was open. Apparently, it's opening up soon. But back when I lived in the DC region, and before the closure of the bird exhibits, they would put on like special kind of show times for the night heron feeding sessions, and you could go and hear the keepers talk about these wild night herons and the Smithsonian's research on them, because the National Zoo is part of the kind of Smithsonian institution. Um, so yeah, that's another quite interesting group. And finally, we have a division between two different lineages of herons. So one lineage leads to the green-backed and pond herons. So the green-backed herons are another like widespread group that you can see like almost anywhere in the world. In fact, they used to be considered a single species, the green-backed heron, but they've been split into multiple since then. And these are quite small herons. And let's see, like yeah, when I lived in Maryland, for example, during the summertime, I would sometimes be able to see green herons when I visited places like big lakes and such. But because they're so small and kind of green, they are a bit better at hiding than some of the larger herons are. So they're not super easy to see, but if you can find them, they're really interesting to observe. And I think probably the most famous thing green-backed herons are known for is that they're one of the herons that will use bait to catch fish. So they'll take like feathers, for example, and put them on the surface of the water, and fish will come over and investigate. Hey, what's this? Is this food? And then they become the food. So that's pretty neat. Pond herons, you are probably not familiar with if you are from North America, but they are found in Afro-Eurasia, and they're a bit bigger than the green-backed herons, and they're often quite beautiful herons. They often have like these brightly, brilliantly white wings, but also a kind of brownish back. So there's this really nice contrast in colors. So the greenbacked and pond herons are close relatives. And then we have the kind of large typical herons. So the herons that I say are typical herons on this slide are basically herons that look heron shaped essentially. So they have this very obvious like kind of sinuous neck and very long legs and such. And pretty much all herons have long necks, but you can see on here like things like the greenback heron and the night herons, they can retract their neck kind of deep into their feathers, so it looks like they have a short neck. And it's only when they want to catch something, like if they go shoot, and you see exactly how long their neck actually is. But things like the large typical herons and the mid-sized typical herons, like you can see that like kind of long neck all the time. And well, at least most of the time. So sometimes if they're feeling relaxed or they're flying, they'll kind of retract the neck back. But yeah, it's a lot more obvious than it is in some other herons. And so the large typical herons are a lineage that includes things like the great blue heron and the gray heron, and also some of the other species that are called egrets, so things like the great egret. And they're another group that are found pretty much all over the world. So yeah, that's an overview of all the herons, and I'm like I said, I'm sure that you are at least familiar with some of these species, no matter where you live, or at least it's very likely that you are. I have another slide on this study just to talk about some of the new discoveries that this study made. But do you have anything to add before we move on?
Well, the only thing that I'll mention is that, I mean, well, for one, I'm like, it's kind of exciting to see a study like this in the first place. But it's funny to see the boat-billed heron here nestled nicely with all the other herons, because
Yeah,
I remember in a lot of older literature, because this bird was so unique in its anatomy compared to the other herons, they would often kind of separate it away from the herons and put it in its own family, so to speak, which seems to be a trend that a lot of the early naturalists have done.
yeah,
So it's kind of cool to see, like in the age of genomics, we've been able to clarify, like, yeah, it's derived, but it's not like so derived that it's not included with everybody else,
right, right. Yeah, indeed. That definitely is a really cool insight from this study. Now, for most part, I would say like much of the study agrees with kind of the smaller genetic studies that have been done on herons before. Yeah, I would say probably the most or at least the most uncertain placement that is shown on this slide is probably the forest night herons. There has been some kind of debate over whether they're closely related to the true night herons or not. In this study, they favor the idea that they're not, but they did find that depending on which parts of the genome you sample, you can get different results for the placement of the forest night herons. So yeah, there's still a little bit of controversy in that regard. But still, they do think that this, at least given the data, is the best supported hypothesis at the moment. Now, because this study sampled so many different species of herons, it was able to shed light on some species that either had not been sampled before or were or had very uncertain placements. And so I'll discuss some of these on the next slide. So first up, the agami heron on the left here. I mentioned that earlier. So they found the agami heron to kind of be sister group to all the other herons except for the tiger herons and the boat-billed heron, which is kind of a new result because in previous studies, sometimes been found to be kind of more closely related to the more typical-looking herons. And in terms of like its overall body shape, it does look a lot like a typical heron. It's just the coloration is very unusual. So it certainly seemed like a reasonable hypothesis. But according to this study, it seems that it's kind of like relatively distant to most of the other heron species. So that's quite an interesting position for it. They also were able to clarify kind of interrelationships among the bitterns. So there are two species of small bitterns from the Americas, the striped back bittern and the least bittern, which are shown on top here. They found that these two species are actually more closely related to the more large-bodied bitterns, the more large-bodied bitterns, than to other small bitterns. So that's interesting, and that requires us to kind of change your scientific names because classically it has been assumed that, well, the big bitterns were one lineage and the small bitterns were another lineage, and the big bitterns were all classified in the genus Botaurus, whereas the small bitterns were classified in the genus Ixobricus, including these two. But if these guys are actually more closely related to the big bitterns, then it's probably simpler to consider them also members of the genus Botaurus instead. And yeah, that's pretty interesting. And actually, it has been suspected before that these species are more closely related to the big bitterns, like even just based on anatomy. So it's interesting to get that confirmation. On the bottom here, we have two very poorly studied species of herons, the white-backed night heron and the white-eared night heron. So the white-backed night heron comes from Africa, and the white-eared night heron comes from Asia. And so these are two nocturnal species of herons, as their name implies. And I think these are probably the cutest looking herons. They have really big eyes. You can kind of make that out on the picture here. But they're not very well studied, and especially the white-eared night heron is actually highly endangered because it has very small population size. And in fact, I wasn't able to find a photo of this heron that I was free to use, so I had to put like an illustration instead, and that was in public domain. And so classically, at least in recent times, these two species have been considered to be closely related to the forest night herons that I mentioned earlier, so the ones that are oddly common in Taiwan. But the study here suggests that they are actually not closely related to those other nocturnal herons. Instead, they are members of the mid-sized typical heron lineage, so they're more closely related to things like the little egret and the snowy egret and the black heron than to the Malayan and Japanese night herons. And as a result, the author suggests that they should also have their scientific names changed. They shouldn't be in the genus Gorsacius, which is the genus of the forest night herons, and instead should be kind of reinstated because it used to be that these were considered like members of their own genus, Calherodius, and so they suggest bringing this name back for these two particular species. So that's pretty cool because we didn't know very much about these herons before, and this is not very scientific, but just by vibes, like in general appearance, looking at these herons, I would say, yeah, they look more like a typical mid-sized herons than like forest night herons, like having observed members of both of those lineages in the wild. Like even though they're nocturnal, it does make sense to me to place them there. And finally, we have a species from New Guinea called the forest bittern, shown here on the right. So this species had not been included in any kind of previous genetic phylogenetic study of herons before. And unfortunately, the data that they got from the specimens of the forest bittern was like not particularly high quality genetic data, so it wasn't especially complete. And as a result, they point out that they still could not place it like very confidently in the heron family tree. But something that all of the results share is that something that they can be relatively confident in is that the forest bittern apparently is actually more closely related to the pond herons, and so in turn, it's also closely related to the green-backed herons, and not to the tiger herons, which is interesting, which is kind of counter to what's been traditionally considered to be the case. And you can see that the forest bittern has a plumage pattern that's very similar to tiger herons, very stripy. But it's in fact, according to the results, more closely related to pond herons. And from a biogeographic standpoint, I think this actually makes a lot of sense because pond herons are found like across Afro-Eurasia, and the forest bittern is from New Guinea, so you can see how like a lineage of kind of offshoot could easily get to New Guinea from where they are, whereas tiger herons are primarily found in the American tropics. Yeah, I think another surprise, but in some ways also makes sense. And so, yeah, that's finally kind of this overview of what might be a very arcane paper, but I think for those of us who are into bird phylogeny, a very exciting paper. Do you have anything to add before we go on to the next one?
Well, the only thing that I'll add is like I agree with you completely. Like, for how seemingly maybe small this paper is, like, no, it's important to have these sorts of clarifications for understanding the history of the group. I mean, if you have all these previous studies that don't even bother to include many of the other types of herons, well, how are you going to know their relationships with each other and then be better informed about their evolutionary history? No, I love stuff like this, and it's kind of cool to see like a little bit of taxonomic changes too that come about with papers like this. Like, oh, this genus actually is more closely related to this one, and I think that's fantastic.
Yeah.
And it's very interesting that you picked a paper like this because for my second, and I guess technically my only story um, for this episode, well, it's two stories, so I guess that technically counts.
True. Yeah.
um, but they are related together. It was if we move to the next slide, um, there was a really fun coincidence that happened in January with the appearance of these two papers on caecilians within just a few weeks of each other, that highlighted aspects of their past and their present. So though, just to clarify, caecilians are one of the three living clades of amphibians, alongside the salamanders and the frogs. But they're particularly strange and rare amphibians. They inhabit most moist tropical equatorial regions, and they have bodies that are legless and worm-like. In fact, they most of them don't even have a proper tail.
Yeah.
Like their bodies end where their hind limbs would be.
Mhm.
Um, so it's very strange. But like, don't be fooled. Caecilians are predators. They have sharp, curved teeth for snagging small invertebrates, including the earthworms, which they closely resemble. Which is kind of funny if you're if you're a drunk earthworm and you're burrowing home one day and you come across a big earthworm, like, oh, it's not an earthworm, get out of there. Little Sicilian humor. Um, but our first paper concerns their origins and relationship to other amphibians. So this is actually a really neat area of research. A common model for the evolutionary history of the living species is that they are all close relatives in a clade called Lysamphibia, which means the smooth amphibians, to distinguish them from the myriad other types of fossil forms that often have really like bumpy or like scaly skin, that are either close relatives or resemble them in appearance and lifestyle. Of course, in the days when Linnaean philosophy ruled, any non-amniotic tetrapod, that is, those that do not lay hard-shelled eggs ancestrally, would have been called an amphibian. So anything from like early tetrapods, like Ichthyostega, all the way to the living groups, they'd all be kind of lumped together as like an amphibian type, so to speak. But we now know this usage is paraphyletic because it excludes the amniotes, whom descended from them, and also just encapsulates such a large number of animals that are not all close relatives of each other in relation to the amniotes. So that said, modern research has indicated that the living amphibians, again the Lysamphibia, may belong to a larger group called Temnospondyli, which flourished during the Permian and Triassic periods alongside the various types of reptiles and proto-mammals, but have since, given way to the smaller but no less prolific amphibians today. But there were some problems here. For one, while we had discovered Permian and Triassic fossils of stem salamanders and stem frogs, and even groups that are basal to both of them, we didn't have any such fossils for caecilians. The oldest was a limbed species called the Eocaecilia micropodia, but that was in the early Jurassic in origin. And for another, there was a slight controversy. Despite what a lot of genetic studies were showing, maybe caecilians were not, as close relatives of these salamanders and frogs as we tend to think. Maybe they're descended from some other type of amphibian like tetrapod, and maybe there's some business in the lower parts of the tree that are responsible for that. And for one, the fossils that we had didn't have enough anatomical features to link Eocaecilia and the living caecilians to the other temnospondyls. They're just so derived in their anatomy that it was very hard to tell.
Mm-hmm.
And this is where Ben T. Kligman and colleagues came in. Their research in the Chinle Formation of the Petrified Forest National Park in Arizona, the famous site with all the dead trees, which is dated to the late Triassic, so between 223 and 221 million years ago, has revealed a new fossil species. Now, this form, which is named Fungus vermis gilmori, proved to be a stem caecilian, an old lineage laying on the branch outside the living caecilian's common ancestor. Now, if that name sounds funny, that's because it's completely meant to be. So, according to the authors, while the fossils were being excavated, the 1972 song Funky Worm by the Ohio Players was often playing in the background. Now, given that caecilians are indeed kind of funky worms, the genus for the fossil was a Latinized funky worm, Uncus and vermis. So it's kind of a situation that recalls the famous story of Lucy the Australopithecine. Of course, Lucy is a nickname. They never actually incorporated it into the species name like they did here, which I think is genius. So, what is so funky about Fungus vermis? Well, in terms of the overall fossils, we have some jaw and skull fragments, some of which can be seen in the top left and in the top here of the slide, and some postcrania, including femora. So, like Eocaecilia, this genus would have been a limbed caecilian. The teeth are pedicellate, so they have the tooth crown and the base of the tooth connected by a layer of dentine, and so that gives the tooth kind of a stalked appearance, which is something we see in both living caecilians as well as in some salamanders and frogs. Now, one link for the three groups, and something that is also shared with a subgroup of temnospondyls that are called dicerophoids, was also noted with these appearance of the teeth. In fact, in terms of the jaw morphology, there were some direct links that can be made between living caecilians, Eocaecilia, Fungus vermis, and then one genus of dicerophoid in particular, Dulciserpiton. So we can actually see the change in these skeletal features towards the living caecilians in these kind of representative fossil groups. Again, that's not implying that Fungus vermis evolved into Eocaecilia, which then, no. It's just they're placeholders for what are otherwise general terms, or general changes in the fossil record. So just to kind of keep that in mind. So we're not saying that Fungus vermis is the ancestor of all caecilians. It could have been, but I mean, there's no way to really test that anyway. But the link with dicerophoids is particularly important because the phylogenetic analyses done with the fossils, because we were able to do that here, shows unanimously that not only were all of the modernless amphibians close relatives after all, but they were indeed nested within the temnospondyls as a type of dicerophoid, with Dulciserpiton as the outgroup branch to Aulus amphibia itself. So it was kind of nice to see that all these things ended up coming together in the end. And so now we have perhaps a little bit more details on what the early history of caecilians was like.
Mhm.
Now, before we move on to the second paper here, there is one important aspect that was recovered in the study. Now, the anatomy and locality of Fungus vermis revealed a new understanding about the origin of caecilians. For one, even though the living caecilians are mainly burrowing animals, Fungus vermis shows little to none of the adaptations for that behavior,
Hmm.
which is known as fossoriality. The skull does not seem to have, well, the skull does seem to have been strengthened at least and a little bit more compact in shape, which is in a way that could allow its head to kind of push through soil like the living forms. But many aspects of the bones are, missing in the stem caecilian that are kind of conducive to a fossorial lifestyle. This suggests that the path to like these burrowing behaviors in the living caecilians was actually a very gradual one. It didn't come until much later in the Mesozoic when Eocecilia was around. Um, but in the second case, we can at least be fairly confident now that the tropical wet-loving temperament of caecilians was around since the beginning, as this part of the Chin Lake Formation during the late Triassic was in an equatorial region and was dominated by humid and moist conditions. And so, as Pangea broke up, as it was connected at the time, it seems that caecilians and their immediate ancestors managed to stick around in these longitudes right up until the present day. And so that further implies that caecilians, on top of their other weird features, are kind of relic
Hmm.
species that have kind of conserved their biology for over 200 million years. And that's pretty funky to me.
Yeah, yeah. Hmm.
Do you have any comments on Fungus vermis before I move on?
Oh, I mean, it's an incredibly cool find, and yeah, like the origins of caecilians and of like the modern amphibians in general, to be honest, is has been such a long-standing controversy, and we could easily spend an entire episode just going over the history and all the different hypotheses that have been proposed regarding their like deep evolutionary origins. Um, but this this is a great discovery that really adds like kind of a major piece of the puzzle. I think, without being an amphibian expert myself, but that's certainly what it looks like. And yeah, I'm sure this is not the last word on like Sicilian evolution by any means, but I think they've definitely made a very solid case as far as I can tell for what they found. And yeah, I look forward to finding out more about Sicilian evolution and about Fungus vermis specifically.
Yeah, me too. I mean, certainly, like, I'd love to see what a complete fossil, like a
Hmm.
complete skeleton, would look like.
Yep.
Because like they implied that these fossils are kind of up in the air for a while,
Right.
and they had gone back to the site and they had just found so much more from these animals. So like we're probably going to be expecting more descriptions in the near future
Right.
regarding like this locality and this particular species, which that's kind of exciting. Like, so like this is probably not the case of like the one fossil that we have. Like there's probably a whole bunch that they got to sift through.
Right.
With the animal, as you can see here, um, like this part of the jaw in the second image on the top, that little bar there is a 1 millimeter. So this is a tiny animal, a tiny caecilian. Um, so like the certainly there's a lot that could be overlooked
Hmm.
if you're especially if you're looking for larger fossils.
Yeah,
But
exactly.
that's why you got to have the right kind of team, and you guys certainly did their work for sure. So okay, our second study brings us to the present day, to the Holocene of northwestern South America, and here we have a perfect example, I think, about how zoologists study species and recognize new ones. So, once upon a time, in 1942, American herpetologist Emmett Reed Dunn described Caecilia degenerata from the Cordillera Oriental of Colombia. Now, the degenerate nature was based on the lack of secondary grooves, that is, the body segments on a Sicilian. and as well as the lack of subdermal scales seen in the caecilians. Yeah, like caecilians actually have uh, little scales in their skin,
Yep.
which is relatively little known. Now, he based this classification on a number of specimens that he collected. But when another American herpetologist, Edward Harrison Taylor, examined Dunn's specimens in 1968, he thought that one of them was different enough in shape, color, and tooth anatomy to be considered its own species, which he called Caecilia corpulenta. Now, the problem was Dunn was not very clear about just where he picked up his Sicilian specimens in the Cordillera Oriental. So for many years, Taylor's holotype lacked a locality.
Mm.
So fast forward to 1996, when a Colombian herpetologist, Pedro Miguel Ruiz Carranza, and colleagues managed to actually locate living specimens of Caecilia corpulenta in Colombia. Um, but it was soon found out that even these were misidentified with respect to their location in the country. And this was something that yet another American herpetologist, John Douglas Lynch, missed when he did a survey in 2000 of the Sicilians of Colombia. And in his analysis, Lynch also expanded the use of the name Caecilia degenerata to include a wider range of the Cordillera Oriental than Dunn had previously suggested. So this is a long way of saying that a bunch of herpetologists with good intentions got very confused by these Colombian Sicilians and just left a bit of a taxonomic and geographical mess that this current paper tries to solve. In fact, Lynch is one of the co-authors alongside Juan Fernandez Roldan and Guido Fabian Medina Rangel. Now, looking into all these past collections, the trio analyzed their anatomy and dimensions using dissection and stereoscopes and other means just to get as many accurate measurements as possible, as well as some very clear photographs, as you can see here on the bottom, of the specimens themselves. You can even see the one on the bottom here has the mouth open, so you can really kind of see like just how serious these teeth were
Yep.
in some of these Sicilians. In all, the team were able to sort the matter very well. Caecilia degenerata was found to be a valid species, but it did not live in such a wide range across the Colombian mountains as was earlier suggested, only within the southeastern areas. So that means that the other specimens that were assigned to this species, that were included across much of the Cordillera Oriental, were then found to be three distinct species in their own right, based on their measurements. Now, the first, which is shown in a full body pose here to the left, this is Caecilia aetylolepis, which is the most widely distributed of the new species. So it occurs throughout the north and southeast of the Cordillera. And it differs from Degenerata in that it actually does have secondary grooves after all, as well as subdermal scales. So that was a thing that was missed when the original authors were working on these specimens. And then there's Caecilia epicrianosoides, which was located much further to the southeast and even into San Cristobal, Venezuela, as it turned out. And this one is represented by the topmost head here at the bottom. And it also sports secondary grooves in contrast to Degenerata, again, another thing that was missed. And then there's Caecilia macrodonta, the big tooth form from the far southwest, and represented here by this toothy face below. Now, like Degenerata, it does lack secondary grooves, but it has a larger terminal shield than the former, that being the end of the body where the tail would be. As I mentioned, Sicilians, most of them don't have a tail. The body just kind of ends where the legs would be, which kind of makes it funny. So, like, if you look at a Sicilian, like the I guess the vent
Yeah.
is very prominent, and
Yes.
it's just that's just how the body ends.
Yep.
Like there's nothing else there. It's very funny. Um, Now, as for Caecilia corpulenta, the team were able to kind of crack the mystery of its locality. It actually didn't come from Colombia at all. It's a Peruvian Sicilian that's just somehow got mixed up in the original descriptions that Taylor was writing. Um, Now, if all this seems trivial, I would argue that it isn't. Sicilians as a whole are a very understudied group. has gone through some remarkable transformation and understanding over many decades. I mean, when I flipped through my copy of Hans Voss Reptiles and Amphibians of the World, which is from 1958, it talked about 70 species of caecilians that were known at the time. But if you look at the very well curated database at amphibiaweb.org, who usually keep track of all these different papers, they list at least 215
Oh my goodness.
species of caecilians. And just in terms of that diversity, we're finding with papers like this that we know so little.
Yeah.
In fact, the team itself states in their paper that the neotropical, that is the tropical American caecilians, are actually currently undergoing more pending taxonomic revisions of this sort that are revealing all of this kind of hidden diversity that was previously unknown. Like in just this paper alone, we've gone from 2 misunderstood caecilians to 5 newly understood species. And in a time when the global amphibian diversity is in decline from human agencies, I think it's more important now than ever to understand just what's out there. And if it means taking these delicate instruments to meticulously count the secondary grooves and subdermal scales of caecilians to tease out new species, then I think we should highly encourage that. So it's kind of neat to see um, 2 studies of this sort that are revealing so many new details about the history and diversity of caecilians, and it's kind of cool to kind of include them together in a presentation like this.
Yes.
What do you think, Albert?
Definitely. And yeah, I wholeheartedly agree with your assessment of the value of kind of this kind of detailed taxonomic work. Um, and it is important for us to know what the diversity of life is like out there, so we can not only understand it but also conserve it insofar as we can. And yeah, it definitely does not surprise me that there's so much hidden diversity among caecilians because, like you and the authors mentioned, there's such an understudied group, and there are some understandable reasons for why that is. Because, yeah, they spend most of their lives underground, at least most of the species do. So it's hard for you to just come across them, and um, they often live in regions that are pretty difficult to access, like mostly places like tropical forests. Um, and yeah, so it doesn't surprise me that uh, there is such kind of underappreciated diversity among caecilians, but it's great to see that we are making such good progress. And definitely this kind of taxonomic revision, like going back and checking and seeing like what mistakes like earlier authors potentially made, it requires some really meticulous work, and so I definitely have a lot of respect for researchers who do this kind of work. Um, and I guess before we move on, I just want to say in general that I really like caecilians. I've always been fascinated by them since as long as I've known about them. When I first learned about them in probably my animal books when I was a kid. Yeah, there are so many weird things about their biology. Like just off the top of my head, some of them feed their young with their own skin. Um, yeah, like mother Sicilian will just like grow a special layer of nutritious skin for babies to eat, and they kind of continue regrowing them over a period of time until they grow larger. Um, and some of them have retractable eye stalks, which is kind of wild. Like they have a little stalk like can pop out and make their entire eyeball like come out of their head. It's very weird. And I think just in the last few years, it was discovered that caecilians are potentially venomous, which is something we didn't know about. They secrete at least toxins in their mouth, so potentially it has a function subduing their prey, perhaps. And yeah, so many cool things about caecilians. I'm sure there's so much left to learn about them. I have been lucky enough to have seen a couple species in zoos. Mostly, the ones that are most commonly kept in zoos are the aquatic species, the ones that spend their lives underwater. And definitely, I have been able to observe, like you described earlier, like the position of where a caecilian's kind of, posterior opening is on their bodies, and it is very strange. Because yeah, there is no tail really. It's just like a hole just opens up at the back of the body. It's quite a sight to see, and yeah, very weird anatomy, very mysterious origins, and I am definitely also very happy to see these couple of studies come out in the last couple months. Just kind of clarifying so many different aspects of their biology from both kind of paleontological and also neontological standpoints. Um, so yeah, this is a really wonderful set of studies that you have picked here. So um, that's that's my spiel.
Yeah, no, I couldn't agree more. I couldn't agree more. Yeah, that's kind of funny, like to kind of like tie things around. Um, Nigel Marvin was advertising a new show that he's working on, Wild San Salvador,
Ah,
and like he puts very prominently in the trailer, or at least in the opening of the show, that he gets to hang out with a big Sicilian, and he puts it right in the camera. So I was like, oh, great, a little more, more good press
right,
for
right.
an under uh, underappreciated group of animals, I think, to the general public, to the point where like people don't even wouldn't even know what they are.
Yeah, that's really cool. All right, then. I guess we can continue then to my second story and our final story of this episode. We're going to go far back in time for this one, even further back than the Triassic. So, this is a story about a fish from the Carboniferous period, roughly 300 million years ago. So, this fish is called Iniopera and was found in the western United States. And this fish is a species of cartilaginous fish, so it's a member of the lineage of fishes that includes sharks and rays, with mostly kind of cartilaginous skeletons instead of bony skeletons. But it actually wasn't especially close to the true sharks and rays. Instead, it is thought to be a stem-ratfish, which is the other kind of major lineage of cartilaginous fish that is alive today. And I don't think we've really talked about ratfishes on this show before. Um, and they're a group that I think not many people are likely to be familiar with. The cartilaginous fishes that are alive today are divided into kind of two major lineages, and one goes to the sharks and rays, which most people know about, and then the other one goes to the ratfishes, which most people probably don't know about. Um, the ratfishes, they're a pretty strange group. Most of the living ones, spend most of their time kind of near the seabed. A lot of them are deep sea dwellers. Um, and I think the reason they're called ratfishes is they tend to have like very long, skinny tails. So that kind of vaguely makes them look like a rat, I guess. Um, Another name for them is rabbitfish, actually, and the reason for that is actually kind of related to the topic of the story, because they have these very prominent teeth that are good for crushing things. Might be reminded of like the big incisors of a rabbit. And yeah, they're a pretty strange group of fish. Sometimes you can see them in aquariums, especially there are a few species that are like relatively commonly kept in aquariums, like the spotted ratfish. So if you're lucky, you might be able to see them um, in captivity. But nonetheless, they're not very well known. Some of them are very strange looking. Like there are some that are called like elephant nose chimeras. So chimera is another name for ratfish. Yeah, they have a lot of different common names, even though they're not very well known. You have ratfishes, rabbitfishes, chimeras. But yeah, some of them have like this kind of odd looking cartilage that protrudes from their snout, and so they kind of vaguely resembles an elephant's trunk, so they get called elephant nose chimeras. Yeah, all kinds of weird and wonderful morphology in this group. But most of the modern ratfishes are kind of vaguely samey, you could say, like in terms of their ecology. So, like I said, they mostly hang out near the bottom of the seafloor, and they have these crushing teeth. They feed on like hard-shelled prey items they can pick up from the seabed, like mollusks and crustaceans and such. However, we know that in the ancient past, members of the ratfish lineage were a lot more diverse, and so they included things like the Iniopera, which we're going to talk about today, is part of a group of stem stem-ratfishes that had these really big kind of pectoral fins. Like they have been likened to like the pectoral fins of say flying fish, and like people have even speculated, I think, that Iniopera and its close relatives could maybe like jump out of the water and kind of glide like a flying fish can. Um, which would be, I think, the oldest instance of such an adaptation in fishes. But to my knowledge, like this idea has not really been tested very much. I mean, these guys are understudied in general, but yeah, I'm not aware
Mhm.
of any kind of sort of biomechanical study that studies like whether or not this kind of gliding behavior is plausible. And just personally, like as someone who doesn't study like fishes in the narrow sense, um, I the pectoral fins of Iniopera and its cousins, like they don't look that big. Like they're not quite flying fish proportions. I see where the resemblance comes from, but I am a little skeptical that they could actually be used to glide through the air. But who knows? We need someone to do that study. But they're not the only kind of representatives of stem ratfish diversity that we have found in the fossil record. If you are kind of at all familiar with Paleozoic fauna, you've probably heard of Helicoprion, which is sometimes nicknamed the buzzsaw shark because it's got this very strange kind of arrangement of its teeth. Its teeth are kind of arranged in a spiral shape that sits like a wheel in its lower jaw. And yeah, for a long time, it's been debated like exactly how um, this tooth whorl, as it is called, was positioned and oriented. And people have even suggested that it was not like located in the mouth at all. That it was like attached to the tail or something, or like on the top of its head or something. That wasn't actually like part of the jaw. But eventually, like more complete specimens were found that confirmed that it was like in the lower jaw. And so that's a really weird adaptation that we don't see in any kind of living cartilaginous fishes. Yeah, the buzzsaw shark, even though that it's currently with newer studies is now thought to be a stem ratfish and not like a true shark in the strict sense. But you know, people do call like all cartilaginous fishes sharks, like in a informal manner. So it's not completely wrong to continue calling it the buzzsaw shark. Um, and that one actually got pretty big. I think like Helicoprion is one of the biggest Paleozoic fishes that is known. Um, and also things like Stephacanthus. You might know this if you watched Nigel Marvin's Sea Monsters when you were little, or if you've watched it at all. The Stephacanthus is also nicknamed the ironing board shark because it and its relatives had this like really weird dorsal fin that's like kind of flattened out into almost a crest like just behind its head. Very strange. And it seems that this was a sexually dimorphic feature because people have found like specimens of fishes similar to Stephacanthus where like these two specimens are preserved together, and like one of them is like grabbing hold of like the dorsal fin of the other one, and they're otherwise very similar, but the one that's grabbing hold of the other's dorsal fin does not have the a dorsal fin in that shape, and so it's thought that this was maybe like a male and female kind of thing. So maybe the males had those, and then it was used in like during like perhaps this kind of courtship ritual. So that's really interesting. And yeah, it's been uncertain like where in the cartilaginous fish family tree these a lot of these ancient weird chondrichthyans, like chondrichthyans are the cartilaginous fishes, were situated. But recent studies suggest that Stephacanthus and its close relatives are also stem ratfishes instead of true sharks, similar to Helicoprion and its kin. And so, yeah, that's just like a tiny sampling of like all the weird and wonderful stem ratfishes out there. There are even more than that. All kinds of weird shapes and sizes in the Paleozoic. It's wild. Yeah, go look up like fossil ratfish cousins if you have the time, because it's just like incredible how much diversity it had. And in a way, this study kind of adds to that diversity. Even though Iniopera is not a newly discovered species, this new study really clarifies kind of what it might have been doing ecologically. And in this way, it actually shows us that these stem ratfishes were even more ecologically diverse than we thought. So something cool about Iniopera is that it is known from specimens that preserve like the skull in essentially 3 dimensions. So many of these cartilaginous fish skeletons, when they're preserved at all, because remember these are cartilaginous skeletons, so it's not as easy to preserve chondrichthyan fossils as they are for bony vertebrates. Because the cartilage is much easier, it's a softer material and easier to break down than bone is. But Iniopera is actually known from some specimens that preserve the head in 3 dimensions. And so, because of this, the authors of this new study were able to reconstruct the muscles of the head, kind of figure out where the muscles go and how big they might have been based on the complete skull. And from there, they were able to estimate like what kind of movements the skull might have been capable of, and from there understand what perhaps Iniopera was feeding on or how it fed, because that has been unclear until recently. People have interpreted Iniopera as being similar to modern ratfishes, like kind of feeding on hard-shelled prey items on the seabed, but the authors suggest that this is unlikely. In fact, their results suggest that it was not well adapted to doing this at all. It does not have a downward pointing mouth, and you can kind of see that on the image here. So if you need help orienting yourself, towards the right is the tip of the mouth, and towards the left is the back of the head, and you can see the base of the pectoral fins, kind of in the top, kind of left of the skull here. And so the tip of the mouth, you can see it kind of faces forward and even slightly upward. So that is not a very suitable kind of position of the mouth you want to have if you want to pick up things from the seabed. Modern ratfishes, they have the mouth oriented downward, which makes a lot of sense. Kind of similar to rays in that regard. Rays also feed a lot on the ocean bottom, of course. Most of them do, at least. And also, because they were able to reconstruct the muscles of Iniopera, they were also able to reconstruct how hard it could bite. And it turns out that it had a very, very weak bite force. Iniopera does have some teeth. It has small teeth at the very front of its jaws. But the thing is, the front of your jaws are where you can exert the least amount of force with your jaws. And so if Iniopera did not have a strong bite to begin with, like, yeah, the strength of its jaws, like at the tip of the snout, would have been very feeble and very unsuitable to kind of crushing anything. So they suggest that it's unlikely Iniopera was feeding on hard prey items on the seafloor. So in that regard, not like a modern ratfish. So what was it doing instead? Well, they notice a few things that are indicative of a very different kind of feeding style. So where Iniopera does have strong kind of muscle attachments is to the pectoral girdle, so the shoulder girdle. So it's kind of weird to think of fish as having shoulders, right? But they do have a kind of skeleton to attach their pectoral fins to, and that's kind of homologous to our shoulder girdle. Now, fishes do not have a neck, so their shoulder girdle usually attaches directly to the skull, and you can see that in the image here. So it's got big muscle attachments on the pectoral girdle, and also big muscle attachments on the hyoid. So in us, the hyoid is kind of the attachment for the tongue. So what does this indicate? Well, it turns out that having kind of big muscle attachments on these parts of the body, but not so much muscle devoted to kind of closing the jaws to bite force, is more commonly seen in fishes that suction feed. In fact, I would say vertebrates that suction feed. So that's when you, instead of specializing in kind of closing your jaw really hard, in a way it's kind of specializing in opening your jaw really hard. This is a very useful kind of feeding method in the water, because you can suddenly open your jaw and suck in a bunch of water, and with it, you don't even have to get very close to your prey. You can just kind of approach them up to a point and then kind of suck them in with the water when you open your mouth. So a lot of fishes feed in this way. And in addition to kind of big muscle attachments on these parts of the skeleton, Iniopera also had a very narrow mouth, and you can see that on the image here. So on the three kind of images on the left here are viewing the skull from the side. But on the right, those three images, you're viewing the skull from the bottom. And so you can see towards the right there, the tip of the mouth is very narrow in Iniopera. And so that's exactly what you want if you're a suction feeder. You want a very narrow opening to your mouth, but being able to expand the back of your kind of oral cavity or throat to be very wide, so you can suck in a large amount of water into like this very narrow tube, and then hopefully like engulf your prey along with that. And so the way they think that this works, so they didn't like reconstruct the exact kind of feeding process of Iniopera in detail. But what they were able to show was that when the hyoid and the pectoral girdle kind of retracted, they could create a large space inside the throat of Iniopera, and the kind of blue that you see in the figures here is basically the amount of water that would enter the oral cavity at different stages of its jaw opening. So you can see that as it opens its jaws and as the hyoid and the pectoral girdle kind of pull back, the amount of water that it can swallow is like becomes much greater, and so it seems that these are likely to be adaptations for suction feeding. And now this is very special because even though a lot of fishes today suction feed, uh, we did not have any evidence that any members of the ratfish lineage suction fed at all prior to this study. So the modern ratfishes, of course, are very specialized for biting, so they just kind of grab their prey and crunch it up. They're not suction feeders. And up until now, we hadn't really identified good evidence of suction feeding any of the fossil ratfishes either. But now, with this new study on Iniopera, we find suction feeding adaptations in this lineage, which is something that had been completely unknown before and kind of expands our view of what they were doing back in the Paleozoic, which is really amazing. But not only that, because it turns out Iniopera was also special, not just in the fact that it's suction fed, but also in how it's suction fed. Because in some ways, the structure of the skull of Iniopera is actually not so similar to what a normal fish skull would look like. So in a typical fish, like in most sharks, for example, or in most of the ray-fin fishes, so most of the fishes that you can think of today, there are several kinds of suction-feeding sharks, and many of the ray-fin fishes are specialized suction feeders. But they suction feed in a very different way because in fishes, the upper jaw is often not kind of fused with the rest of the skull. So that's a very odd concept for us because our upper jaw is fused with the rest of the skull. It can't move independent of the rest of the part that contains our brain, for example. But in most fishes it is. So in most fishes, like the entire upper jaw can kind of extend forward. And so in a lot of the suction feeding ray-fin fishes, for example, it's kind of the combination of movement of the lower jaw and the upper jaw kind of moving forward that forms a tube for them to suction feed with. And furthermore, there are also like other regions of the skull that are mobile too, like the back of the skull also tends to move up, kind of flexes upward when they suction feed, and that's not the case in Iniopera. Iniopera actually, like modern ratfishes in this regard, has the upper jaw fused with the rest of the skull, and in this way it's also similar to us, land vertebrates. So it cannot suction feed by kind of moving parts of the upper jaw like a modern like the ray-fin fishes can, or like some of the sharks can. Instead, the suction feeding mechanics of Iniopera appear to be more similar to suction feeding tetrapods, so four-limbed vertebrates like us. And now, four-limbed vertebrates, most of us live on land, but there are some of us that have gone back to the water to live. And some aquatic tetrapods do suction feed. A very famous example is the mata turtle of South America. Actually, I think they've been split into several species now, so I should say mata turtles of South America. Very, very weird-looking turtle. Turtles are already incredibly weird, but like the mata turtle is like weird even among the turtles. And that is a very odd specialized suction feeding turtle, or I should say set of a species of turtles. There are also some species of like aquatic amphibians that suction feed, like the Suriname toad, which is also a very, very weird species of frog. There are also some aquatic mammals that suction feed, things like walruses will like suck things up from the seafloor and things like that. And there are also some whales that suction feed too. Because the upper jaw is fused to the skull in all these tetrapods. It turns out the way that the suction feeding works in Iniopera actually appears to be more similar to tetrapods, ironically, even though cartilaginous fishes and tetrapods are very, very distantly related. Like, you're more closely related to a goldfish than to a shark, and yet the stem-ratfish has converged on like a feeding method that is more similar to tetrapods than to anything else. And it seems to be something that most of the other ratfishes were not doing. This is a really amazing study. I mean, we don't get such detailed studies on the lifestyles of Paleozoic fishes all that often, and certainly ratfishes are an incredibly fascinating group to be working with. Yeah, I thought this was a really interesting paper. What do you think?
Yeah, I think so as well. And as you're describing the mechanics of the of this fish, you know, it really has me thinking back to some other studies that we've talked about on this show, like regarding like placoderms, for example,
Mm-hmm.
where we're kind of seeing now that, great experiments in, body shape, feeding, mobility were going on relatively early in the history of vertebrates, like more than we thought that they would.
Yeah.
Like it's not so much a simple case of like simple fishes to more complex
Right. Yeah.
fishes. Like we're seeing a lot of what we see in present day biodiverse oceans and seas and freshwater areas. We're seeing that back in the past in the Carboniferous and the Devonian. So I think it's kind of interesting to see a study like this just kind of add further support for this new understanding.
Mm-hmm.
To have like a, a, a ratfish converge with tetrapods more than other fish in terms of suction feeding, like that's right up there with like Helicoprion
Yeah.
and Stephanopithecus as just one of the weirdies of the past. And there's just so many of them that kind of defy what we think about in the present day in
Right.
terms of what can vertebrates do, what can vertebrate evolution do, you
Mm-hmm.
know? Um, so yeah, I'm very excited about this paper. That's kind of cool. And I am definitely a little bit familiar with Iniopera. As you described, the flying fish model I've seen more than once,
Yeah.
interestingly. Um, Rarely illustrated, but
Yeah.
yeah, like looking at the fossils and like something like this, like yeah, it is kind of weird that that was described in the first place
Mm-hmm.
because like a flying fish, like the anatomy of the fins to allow that sort of behavior is quite different from this.
Yeah.
Just kind of based on what I'm seeing, like the fins themselves look very bony,
Right.
well, cartilagey, I guess,
Yeah. Yeah. Skeletal.
for right, yeah, like for what it's trying for what it's doing, like to be like a flying fish, for example. So
Right.
I think it's one of those things where it's like it looks similar only at like a very passing glance,
Yeah.
but like if
Right.
you really like spend some time looking at the fossils, like it's kind of weird that like that idea came about in the first place.
Right.
Yeah, I mean it's kind of like that really old idea for longus squama, like
Yes.
that weird diapsid reptile that has defied classification for so long, and you get people who try to ally it with birds, for example, even though like
Yeah.
there's no evidence for that. But like I've seen some reconstructions of this fossil where so this animal is small and it kind of has like a row of like leafy um
Things.
extensions all along the back.
Yeah.
Very bizarre. And a lot of people have looked at these structures and tried to figure out, well, what could these be used for? Now, personally, like, and I follow some other researchers on this. I think that it's just as simple as display.
Right.
So, I mean, like, display function in animals always kind of defy expectations
Yeah.
anyway. So, like, why should we be surprised with the Triassic reptile?
Mm-hmm.
No less. But some people have tried to take this and say, well, they kind of look like wings or feathery structures. Maybe there was two rows of these
Right.
things, and his animal kind of fluttered about in the air. Um, but it's like, okay, if you actually look at these things, like no flying animal has structures like that
Yeah.
to make it like lift up in the air. It feels like you're extrapolating more than you can actually see in the fossil.
Yeah. Yeah.
And like I know some other researchers have looked at this and they even think that the structures themselves probably aren't even a part of the animal to begin with. Like the animal died over like a plant or
Mm-hmm.
something, and then like it just looks that way. I don't know if there's any merit in that
Right.
nowadays, but like it's basically this is a long tangent in saying like just because an animal looks like a fossil looks like a living animal today, it doesn't necessarily mean that we can just copy and paste
Yeah.
behaviors based upon very superficial similarities.
Mm-hmm.
To see, something like Iniopera with fins like that flying. Well, because like maybe, I mean, there's always the benefit of the doubt, but I think at the moment, I'm kind of surprised like that was even an idea to begin with. Basically, what I'm saying,
Right, right,
because like the fin looks smaller than the head,
yeah.
unless like that's just preservation and
Right, yeah.
it would
It might
actually,
extend out a bit further than that. But yeah, still like the total size of those things from what I've seen are not that big. Yeah.
yeah. But like either way, like we have a study like this that shows like okay, well maybe if it wasn't like a flying fish, it's still really weird,
Hmm.
like a flying fish. It's just in terms of its suction feeding
Yeah.
and what it was doing compared to its other relatives. Um, so no, this is great. I love the biomechanical studies. I always gush over them, and it's kind of cool to see one on a relatively obscure fish
Yeah.
to begin with.
All right then. So I think that's the last of our stories. So do we want to go on to the end matter?
Yeah, sure, sure. So thank you all so much for joining us. We are on Patreon, so that's patreon.com/time and clades. If you're interested in contributing monetary donations for our program, we always appreciate it. It always helps us out. And of course, your contributions will help us continue the series and develop new projects and expansions. We currently have three patrons now that we are very grateful for. They have tiers that they've chosen where they get shout outs. So we want to give special thanks to our friend Denver and our patrons Paul and Frankish. So thank you very much for helping out with the show. Of course, other acknowledgments are in order. We want to thank our good friends Henry and Alicia for their contributions to this series. Henry, of course, is responsible for the wonderful theme music that always opens our shows. And Alicia is responsible for the color scheme of Albert's Alvarezsaur Avatar. Very great artist. And of course, we also want to thank Beth Zeiken once again for letting us use her featured art in this episode for what is probably one of the most amazing studies of last year. Now, we are on Twitter. We are at Time and Clades, where we generally put updates as well as upload episodes that we have aired. But most likely you are watching us on YouTube. That is through Time and Clades. If you want to like and subscribe, we very appreciate it. And if you have any questions for the show, whether it be about the subject material that we've talked about or anything in general, you are welcome to send us an email, timeandclades@gmail.com. Of course, you can also leave us a tweet on our Twitter page, or you can comment on our YouTube comment sections. Any way is feasible. Now, if you want to read any of the papers that we've talked about today, or any of the other references and resources that we've discussed, please go to our description where you can find links to all of these references in the episode. Of course, we will be putting Beth Zeiken's store as well as the Kickstarter for Forgotten Bloodline. So definitely go ahead and check those out. And with that, that is it for our show. As Albert has alluded to, we're going to try very strongly to have just a February episode coming up
Yeah.
next. So we hope that you all will look forward to that as well. Certainly, there's quite a lot of studies to choose from February,
Yep.
so we're going to have a fun time putting it together. Don't you think?
I definitely think so.
But until next time, thank you all so much and have a wonderful day.
Indeed. Take care, everybody.